Hi guys, welcome back to Set Course with Tanya. Today we'll be discussing about a portion of measurement of elements which comes under general navigation. The part 1 of which being point of equal time, also referred as PET. So let's get started. Point of equal time or the critical point or the equal time point is a time-based problem in air navigation. It is that point between two airfields, say our departure and destination airfield, from which it is going to take equal amount of time to go to either of the fields. It helps the pilot to quickly decide which of the two airfield need to be chosen in case of any emergency. The fuel that is being taken for the flight, which includes our trip fuel, contingency, holding, alternate, it is going to be sufficient to reach to either of the airfield. So this concludes that our point of equal time is only a time-based problem and not a fuel-based problem if we are carrying the reserve fuel along. Now, how to calculate the distance and time to reach such point? Let's see. Suppose we have two airfields named A and B. The distance between them being D. If we take our point of equal time as point P and the distance between point A to point P being x, then the distance between point P to B would be d minus x. We also consider that the speed from point A to B of the aircraft was, say, ground speed out. Now the speed, if the aircraft is at point P and has to return to point A, it is ground speed home, which will be denoting as H. And if the aircraft is continuing to point B, the speed is ground speed on, the ground speed onwards, which we'll be denoting by O. Now we are aware of the fact that distance equals speed into time, from which time equals distance by speed. Now, by the definition of point of equal time, we are aware that the aircraft will take equal amount of time to come from point P to A, T1, the same being from point P to B, which is T2. So by definition of point of equal time, T1 is equals to T2. Now the distance from point P to point B is d minus x from point P to point B. So our time for the aircraft from point P to B would be d minus x divided by O, which was our ground speed onwards. Similarly, the time for the aircraft to travel from point P to A would be x, the distance, divided by the speed, which is ground speed home, h. Now, as discussed that T1 is equals to T2 by the definition, we'll be substituting our values as x by h equals d minus x by O. Cross multiplying, we'll have our equation as Ox is equals to h d minus x. Now simplifying this equation, we have our value of x as dh o plus h. So this is the distance that the aircraft is going to cover if it is at the point of equal time and it has to reach the departure airfield, or for that matter from where we are considering the calculation of point of equal time between two airfields. Now we have the distance to reach point of equal time as dh divided by o plus h. Now time to reach point of equal time would be our distance, which is x divided by the ground speed out. If you see this figure, the time to reach from point A to P would be our distance x divided by our ground speed out. Now substituting the value of x, we have time to reach point of equal time as dh o plus h divided by ground speed out. These two formulas 1 and 2 are going to be of utmost importance when you'll be solving your questions regarding to point of equal time. Now let's take an example. So we are given that the distance A to B is 1973 nautical miles. If we suppose the point of equal time as P, the ground speed on is 430 knots and the ground speed back, which is the ground speed home, is 385 knots. We need to calculate the time from A to the point of equal time between A and B. Suppose it is taking T1 from point of equal time to reach to A, and it is taking T2 from point of equal time to reach to B. By definition, we know that T1 equals T2. Then we have time as distance by speed, and our first distance being x and the other one being 1973 minus x. So x over 385 equals 1973 minus x over 430. Cross multiplying, we get final value of x as 932 nautical mile. Now our time to reach would be this one, which is x 932 divided by 385, which comes out around 145 minutes. Now our point of equal time is affected by various factors. The first one being winds. So let's take the first case as the nil wind case. Let's take an example in which the distance between these 2 points being 300 nautical miles, and we are maintaining a constant TAS of 100 knots. P being our point of equal time. Since we're maintaining a constant TAS, our home speed would be equal to our on speed, which is 100 knots. So this distance from A to P being x, the other one being 300 minus x, the time being T1, other one being T2. By definition, T1 equals T2. That means x upon 100 equals 300 minus x upon 100 again. So cross multiplying, we get the value of x as 150 nautical miles, which is exactly midway of the distance of A and B. Now let's take the case of headwind. our two airfields being A and B, separated by a distance of 300 nautical miles. Our home speed as well as the on speed being equal to say 500 knots. And we have a headwind of 50 knots. Now once our aircraft is moving towards destination B, our ground speed would be 500 minus 50, which is 450, as we are getting the wind straight towards the nose of the aircraft. But if the aircraft is going back to its departure airfield, the home airfield, the same headwind will act as a tailwind, thereby increasing the ground speed, which is 550 knots. So as a result of our headwind, our onward speed has decreased and our home speed has increased. Let's take the distance between point A and P as x, the other one being 300 minus x, time t1 and t2. Again, by definition, t1 equals t2 and time is equals to distance over speed. We get the following equation. Cross multiplying, we get the final value of x as 165 nautical mile. So in this case, our point of equal time has shifted towards the destination, as our x is greater than our d minus x. So we can conclude with it that in case of headwind, our point of equal time is pushed towards destination. A similar case of tailwind you can try on your own self, and you'll get to know that in case of tailwind, our point of equal time shifts toward the departure. Now in case of beam winds, suppose we are going from A to B and our aircraft is experiencing winds exactly perpendicular to its track. Now the aircraft will point its nose into the wind to grab for the winds and maintain the track. So in this case, the time to reach point of equal time is going to increase because we are putting a portion of our task to cater for the winds. However, the distance is going to remain the same. So remember the very first formula that we discussed, the formula number 2, which said that the time to reach PET is our x upon ground speed out, or the ground speed full. So this is going to alter as we are catering for the winds, but our distance to PET is going to remain the same. Next factor is the fuel consumption. Now, if the fuel consumption is increasing or if the flight fuel is decreasing, again our distance to point of equal time is going to remain same. Because discussed earlier also, point of equal time is only a time-based problem and it is independent of fuel and endurance. Now another quick summary, that we were calculating the point of equal time because it is a case of emergency. Suppose the emergency is an engine failure. So our ground speed home or the ground speed onward is going to be, say, a single engine speed. But the ground speed out or the full one, it is all engine tasks. And our home speed or the on speed was used to calculate the distance. But in order to calculate the time, we'll be using our all engine tasks. So now let's take one more numerical example, the format of which is being asked in the DGC examination. The distance from A to B being 560 nautical mile. Our task is 200 knots. The wind component from A to B is minus 15 knots. Now A to B, it is going to affect our speed onward, which was task 200 minus 15, which is 185 knots. And the wind component from B to A, like this way, it is plus 15 knots, which increases our ground speed home as 200 plus 15, which is 215 knots. Now let's take the distance A to P as x and from P to B as 560 minus x time T1 and T2. By the definition, we have T1 equals T2, which is x upon 215 equals 560 minus x upon 185. Cross multiplying, we have our value of x as 301 nautical miles. Now we are being asked the distance from point of equal time to B, which is 560 minus x, which comes out to be 259 nautical mile. So in this way we solve our numericals which have a wind component attached with the question. So this was all regarding the point of equal time. If you have any doubts regarding the same, you can just put in the comment section and I'll be more than happy to help you. Thanks for watching. Do like and subscribe for getting latest updates about the air navigation portion of DGCA examination.